Hello, everyone. I'm Ukai from the, Google engineering team, and this is the very last session for this Google Developers Day. First of all, I'd like to talk about the concept of the Google Developers Day. In this session, that we're going to provide the briefings and the products and the technologies of Google. But this session is really a Japan special session, so that in which we would like to talk about some of the inquiries and the questions from the many Japanese engineers and what will be the days of the Google engineers and how we're working on developing the products. That's an often asked question. So sometimes I'm going to talk about some of the recruiting events or some of the seminars and events about how we're working. But so that's often the frequently asked question in Japan. So that's why we have set up this special session for the developers in the Japans. That means that I would like to talk about the software engineers that are the core part of the Google technology. So the title of my speech is that software engineers for Google's. So I'd like to just have some question and answer sessions, so the rest part of it. And to start with, I'd like to introduce myself. Before joining the Google, and I'd like to talk about what I was doing in the Google. And I was studied in the applied mathematics and the Kyoto universities. And so that's now I'm just the one that I don't have any doctorates. But then after that, and I graduated from that's the Kyoto University Graduate School. I worked for the Hewlett Packard and Research Institutes, and also and cultivated software creation business units and the IPA. So I talk about UIM, the JTAG, and the Knopics, and the third DC product dumps, and the Hyper Strainer. How that all the software and the free software related project I get involved with. And on the other hand, when I was in the Kyoto University, I joined at the Kyoto University microcomputer club at the time that the 98s and the 386 BSD, the 98, but it still was in the prevalent practice for that. It was just before the zero. Now I'm just playing that on all these microcomputers, and then also I just working also on the Debian, and which is the free software. So now I've just started up the JP project for the Debian in Japan, and then also I work for some of the package maintenance, and I'm just working for the 30 Debian packages. And I just improved the mirroring environments of the Debian in Japan so that all the engineers can easily installing the package of Debian. And also I work for the snapshot.debian.net. So this is the daily Debian archiving is just collecting by this site. So by taking advantage of these sites, and you can just get access to the Debian package in 1 month or just even in 1 year before. This is the service provided by this. And also I'm the member of the Japan Linux Association. I'm just getting involved in the association. Once I was the chairman, and I get involved in it from the initial stage of the Linux Association. I was just working for that's in the papers, so the free software, the open source, the Linux. If you get involved with and you have any good ideas, would you please submit your ideas to the Linux Association? And then also, I also work on the free software initiatives, and I'm working as a directors and part of the directors of this a non-profit organization. For the maintenance organizations for the software initiatives, and that was just to promote the promotion of this software. And then also I joined some of the conferences and the JPS B3 International Conference and held in Akihabara City last year. So that all the other variety of activities concerning the programming. And then also I did get involved in some of the writing, the books, or the supervising the translations of the binary hacks and the code reading, the code quality. And the reason why I joined the Google, this is an awful and just often asked a question for me, but including myself, that maybe the response from the Google engineers would be that for one thing, we joined the Google because we can have the first-hand experience with the large side, so the infrastructure of Google, and that is you can utilize the services of that kind of by using the UPI. But some of that part of the infrastructure cannot be touched directly, unless we become the Google engineer. And for another thing, and the Google is have a really heavy the customer base and globally, so that if we can just come up with new ideas and new services, and we're going to have really big impact on the whole society and in the world. And also we can work together with that really the excellent engineers in Google, so that we can just improve and brush up around skills by just competing and working together with the able engineers in the Google. And then also the Google is really a unique company, so that we're going to have the unique experience if we joined the Google. That's one of the reasons why we joined the Google. It was 1 year ago, and today is that actually that the very last day of my first anniversary, and I joined the Google on the June 1st last year, and I just visited Mountain View for 3 months after that. And where then we got the training, very initial training for the Google developments way, and we just working together with mentor, and we're in the line that and then also the whether the online training is also really good for the Google, so that some of the infrastructure the library and the Google is using is all this information about that kind of available in that websites, and we can learn a lot. And that's what I spent for 3 months after I joined, and also the other of a lot of the favorable things and events, for example, and all the engineers that they go to the Santa Cruz and they will just join the barbecue party, or just for example Dr. Knus and Donald Cruz, and we're gonna have the dinner with them, or the Google dance is just in the nights of that conference in the Google, we're gonna have some dance party and Google picnic and let's say here too. And it's just the Google has some of the amusement park and Mountain View, so we can play there, and also the hacker picnic. Also, we can have the experience of bean flights together with our senior engineers and the Yosemite, or that kind of all the pleasures I experienced it too. And when it comes to the R&D center of Google, it's the basically, and the first one is that the R&D, and this is the largest scale of the R&D center and the Mountain View in the United States, but it's now not only for the Mountain View and the U.S., and a lot of the R&D center and in New York, and then also other than the U.S., and we have the other R&D center in Zurich and Switzerland, and London, the UK, and Sydney in Australia, and in Tokyo, and also we have the R&D center here in Tokyo in Japan, also the Bangalore and India. So it's just a widespread network of R&D of Google. And for actual activity for each of the R&D center is that it's not that the localize it and the local and the development team, but this R&D center is working together in the sense that as a part of the global project. So although that engineers are living and staying in Japan, sometimes we work together with engineers in the US or the Zurich engineers. So it's not that, and they separated for each and geographically localize it and separate it, and just it's just a seamless concept. But although we're going to have some very good communication with those engineers and staying closer, geographically closer to us, but that will be convenient. But it's not that we're working just separately, that we're working as the team of engineers and globally. And for the job description of software engineers, the first of all is the development of software, and an all the process concerning the development, starting from designing, coding, and testing, and also improving and whole processes and products, and the demonstrations, and everything concerning the software developments are within the scope of our job description. So there was not that the engineers and they're working only on the upstream there's some of the other engineers downstream. It's not that they're all just one engineers, one team is working consistently from the upstream to downstream for everything, and we're working on the project team. And when it comes to the project, there are a lot of projects that's going on in the Google. I have never counted just accurately how many projects are there, but probably with the number of projects are more than the number of engineers, headcounts. Because one single engineer said they get on board in the multiple the project at the same time simultaneously, and if just engineers and come across one of the good ideas, and he just easily to start up their own projects. So it's not that some the directors will make some instruction on top-down basis, but that is a lot of that some the engineers working on the floor can come up with that ideas and starting up the project. So that the team is just a two or six engineers team. Is not that large the group, because it cannot be so agile. So that it's just limited to just a smaller size of project team. And I mentioned earlier, basically we get on board and go to all that the process and the designing, the coding and testing, so that the environment is in make much of the innovations. It's not that we spend too much time on that designing, but anyway, just first we have the rough designing ideas. We just proceed with that all the decoding and the demonstrating version, a beta version. So then after we have come up with that kind of beta version, we can know that what should be improved or not. So then anyway, our basic idea is to come up with as many the demos as possible. So that inter-project communication is really open and effective, so that we use that the IM or mailing list, use it for the communication tools on the docs and the spreadsheets and the wiki or the blog. And sometimes we use the blog or the snippets. The snippets mean that this is just a weekly schedule, and there will be the posted on the snippets. These are the tools we use it. So that we're going to check it out, that the progress for each engineers and project. And also we're going to have the video conference on the weekly basis between the US and the Japan. We also have that kind of communication. And also, there's no any just communication problems in the project. And also in the inter-project communication, it's really smooth. So sometimes the globalization and internationalization, the testing should be done on a global basis. And also inter-project, it should be done on an inter-project basis, so that all the engineers, not only one specific project, but also the engineers over all the project have to know that. So we have that's why we have very smooth communications. Next, we'd like to talk about the development flow within the Google. Some of you are already aware that we have a 20% rule in Google, which means that 20% of our working hours should be spent on, we can spend on 20% on anything we can. So that just in the end, we can take advantage of free ideas. So then after we come up with any good ideas, we have some discussions, and if we can have some specific ideas, then we'll proceed to the next process of design doc. This means that we document the rough ideas, and based on design doc, we proceed with the coding, and we just create the demos. While coding, and some other different engineers are reviewing that the coding, and we're going through that some cycle of the coding and reviewing and improvements. And after and then everything is just completed, that the final coding is committed, and we proceed with that specific programming. And after start the demonstrations, and all the engineers, it is open to all the engineers. Any engineers can access to that demo and the demonstration, so that and the engineers can make the feedback and the comments, and we can make the improvements on across the whole company. And once that's the specific demonstration is evaluated highly and appreciated, that will be that proceed with the Google Love Beta and be finally launched as a product. So once it will be just the product will be launched on the Google, we're going to have the feedback, as many feedback as possible from the global basis, and we can take advantage of the feedback again for the further improving and reviewing the product. This is the basic cycle of the flows. And I mentioned the design doc, and the programmer don't like to just documents that are the ideas basically. So sometimes I get there are many people are surprised that now engineers are working on that, documented with the Google. But in this design doc, first we specify that the background and objective of the specific ideas, why we're doing, and then also that the rough design, and not just so much the accurate and specific, that we don't have to mention any about the detail, the coding, but that the large scale, when the rough, the high level architecture should be described here, and also who are getting involved in that the projects. All the information are in the design doc. So after this, they're making this information available, and someone will just find out that the sources and then some of the internal communications, and they have to know to which they can have the contact with. So that way, specified for all the security and the privacy and the considerations, and are that what kind of securities and privacy issues are related to this in the projects. And all these details are also be included as information in the design doc. And also the testing and the and after the actual operations, and once we have the failure, what would be the monitoring plan, and how we can cut it down the downtime, that kind of all these relevant information of the project and background are all included in this design doc, so that even the third party can easily understand and outline of the project. And first we come up with this document, but And while we're working on the coding, that they will have some discrepancy from this original idea, so that why they still try to use the design doc as part of just a navigation map.
So once the design doc is put together and there's an agreement among the team members, we start coding. C++, Java, and Python are the three main languages that we use for programming. C++ is used for infrastructure related, and Java is more often used for front end. For internal services or things that are used internally for housekeeping, we mostly use Python. Sawzall, this is a map. We use good Google unique language, and this is sometimes used for specific purposes. And today, in Google Developer Day, you have heard a lot about JavaScript. JavaScript is, of course, used. And ActionScript is used for video and finance. So some people use Flash. And all of the codes are managed in one single repository globally. And each team would have their own directory, and they're responsible for that. But engineers can look at any code in any directory in this repository. So the code can be checked, corrected, reviewed, and then if it's okay, it's committed or checked in. And this process is repeated again and again. There are two different types of review that happens. One is conducted by a project owner. Person who is doing the project knows the direction of the project, so there has to be some kind of approval by the project owner, otherwise you cannot change the code. So sometimes a person who's not related to the project can send a patch, and the repository is single. So in some cases, one project is using another project's library and identifies a problem. And of course, you can issue a bug report, but you can also send a patch directly, and this happens on a day-to-day basis at Google. There's another review called readability review, and you need to pass this review. This is conducted for the purpose of integrating coding style. At Google, we are supposed to use the same coding style, so we need to make sure that the code that we write can be read by somebody else and understood. So readability reviewer is defined for each project, and you need to be accepted as a readability reviewer before you can conduct the readability review for the particular project. So how much code do we write? I think you would be interested to find out. This is an example of a developer. This is actually me. I don't think this is actually meaningful, this information, but on a weekly basis, you can see the changes of patches, number of patches. You can see how many patches were written per week. As you can see, there's none written. Sometimes when we're busy, it's about 20 patches that are written in a week. But if you just fix one code, that one line, that's counted as one. If you write 1,000 lines, it's also counted as one. So it is not very accurate. And I have not really counted the number of lines written, but approximately in 1 year, I have touched about 30,000 lines of code. I have written about 35,000 and deleted about several thousand. So about 30,000 lines of code based on what happened last year. I also review other people's codes. 3.5 times on an average is the count of review. In the beginning, I was not reviewing anything at all because I was new and I didn't understand things, and I wasn't asked to review. So in the beginning, it was close to 0. And on average, I reviewed about 3.5 times per week. At Google, people love making graphs and looking at numbers. So this is just my example of working at Google for 1 year. When it comes to senior engineer or fellow, they are writing a lot more. Usually people in high positions write more codes at Google. The development policy is that we try to make everything, or as much as we can, by ourselves. We use open source code sometimes, but it has to be clearly identified and put into a different or separate directory tree so we can clearly separate those from the codes that we have written. We just use open source. We don't really use anything else, because if there is a problem that is identified, if it's open source, there are things that we can do to fix the problem. But if we use proprietary library, for example, and we have some idea about how to improve the code, we have to place a separate request to have it fixed. And that really slows down the development speed. It's not efficient. So we try to make everything from top to bottom. And performance is given extremely high priority. Slow is bad. And we can improve the speed at all sorts of different levels. For example, we have to choose the right algorithm, otherwise somebody will complain. Coding technique details is sometimes reviewed and criticized by other people, so we are trying at every level to make a product fast. And we don't just depend on technique blindly. We take measurements and identify bottleneck to see what exactly needs to be fixed. So we are told to measure everything and quantify everything so we know the difference between before and after the fix. And that's how we optimize the code. Scalability is also important. You don't need to think about scalability too much when you're building a demonstration. But when we launch the product as Google product, we have numerous users placing a lot of requests with the product. So we need to account for that, and design has to account for scalability. We're always aware of scalability. Basically, we use many machines on a parallel basis to improve the scalability. Purchasing a high-end machine or high-end machines would be another solution, but that has its own limitations. Parallelism produces better cost performance. That is our basic policy at Google. Reliability is another important factor. If you use many low-cost machines, that's okay to start with, but as we continue to use them, they tend to break. Hardware tends to break. MTBF, mean time between failure, for this PC, for example, is 3 years. But if we have 1,000 such PCs, it means that 3 years is only 1,000 days, more or less, meaning that there is one PC breaking down every day. We use more than 1,000 PCs at Google, so machines are breaking down every day, all the time, but we still need to continue to provide services to everyone, and that's where we make efforts to build a strong system. We have a replication, meaning that even one machine goes down, there's another machine that will take care of it. If there is failure is immediately identified and fixed. So we're really focused on automation. Testing is also very, very important for us. We are supposed to write our own unit tests for the code that we have written, and unit test can be run automatically using the system that we have. If somebody makes a correction or modification after that, and the unit test doesn't work, we are instructed by email to fix or change the unit test. Let me explain what testing on the toilet means. We have intergrouplet or activity, cross-group activity for testing. And this group of people produce posters that is put on the wall of the toilet, explaining the best way of conducting tests. So we are very active in educating people within Google about the best way of testing. This is what Eric Schmidt says: slow never wins. And we need to take measurement up to milliseconds to make everything faster. And another comment about scaling. World and internet are both big places, so we need to scale to the size of the world and the internet. Next, I want to talk about information sharing. Google's policy is to share information because we want to be creative, innovative. If we don't share, we cannot be creative. So in order to share information, we do everything we can. For example, we have a variety of databases. Project database has all the information about the project progress and who is involved in the project. Idea database has all the information about ideas that you have had. You can submit your idea and it can be reviewed and commented by your colleagues to see whether your idea is good or not good. We also have a bug database. If there is a bug or problem, it can be managed and tracked using this database. Progress is of course written into project database, but we also use snippets. So every week we need to write a report saying this is what we've done this week. And this snippet is open to everyone. So it is very easy to see what other people are doing, what they're having trouble with, and what kind of progress they're making. Some people are writing blog using bloggers. Documents are written very often. We write as many documents as much as we write codes, including design doc, wiki explaining how to use something, or feature policy. We have many pages of wiki. I have never counted how many pages, but it is very widely used. And we are recently shifting to docs and spreadsheets, because if we use docs and spreadsheets, we can edit, share information, and revise information very easily among ourselves. So more people are using docs and spreadsheets. For source code version control, we use Perforce. Perforce is slightly modified for our use. When we do review, we use a system called Mongerian, made by the author of Python. So we can provide each other with comments for source code to see what can be improved or what is working. For communication among engineers, we use mailing list and instant messaging. Google Chat or Gmail Chat is very frequently used. We share one room with 2 to 4 people. We don't have our own rooms. Programmers tend to work in an isolated environment. Some people believe it's better to work in a quiet, isolated environment. But at Google, we share one room with multiple people to write codes, because it's very easy to ask questions when you need to. You just ask the person next to you, how do you do this? And it's so easy. If you're in an isolated environment, you have to go to another room to ask question. It's difficult to communicate. You spend and waste a lot of time thinking about things where you could just ask someone and get the answer immediately. You would just waste a half day, a whole day just thinking about it by yourself. At Google, lunch is provided free of charge. So we go out to lunch together and exchange information. We actively exchange information. We also go out for coffee or play billiards or other games together and talk about what's happening, update each other. Tech talk is another thing that we do. At Mountain View, almost every day. And in Japan, we try to do this as often as possible.
So in this tech talk, that each engineers talk about their projects or about the technology they know. By having this tech talk, engineers can and learn and also talk about a lot of technologies, and also for those engineers who can talk, that they can just organize their own ideas by talking to the different engineers, so that it really advantageous for the old engineers. But it's not that we share all the information. Some of the information are not shared. For example, the user informations are kept confidential. The most of the engineers can touch upon and know about the users and user information. That will be just and some privacy data as well are stored in some specific server and cannot be accessed by the engineers. So they really strictly manage it to keep the confidentiality. And also, not only for that the information sharing, but although that information is available for everyone, but it's not that we don't have any access control. Although they need the authentication so that the system can know who is getting access, but actually there's no control of some regulated access, but there's a specific system of the monitoring that access. Next, I'd like to talk about the daily, and when I look at that's the daily work, and the first we go to the office, and I just read through the email at the corresponding time, and the daytime to the nights in the U.S., so that we have a lot of emails after. Sometimes we have some conferences, but they have to read into the mails, and I will study for the coding of the day. And now we have just lunch break there. It's not just the coding or debugging, it's not so much different, but in this day, specific day, and it looks like that we have some. I get involved in some debugging rather than the coding. And this date happened to be the day I had the interview. And interview means that the interview for the recruiting the new engineers. I'd like to talk about in the details later. And basically, most of the job of the day is the coding, but we're just reading the emails or debugging while coding. But mostly that I coding, and also I had the English lesson on this exact day, and we had a dinner or just a game. We enjoyed the gaming or chatting, and I went home. This is rather the busier days. And usually I come to the office and have a late meals, and I just have a lunch and recording, and just I leave the office. That's the usual day. And sometimes we have tech talk within this schedule. The performance appraisal of engineers of Google is a little different and from the other company. The first, we are just supposed to set up the objectives and the key results, and there's every quarter we ourselves to report that objectives and to what extent we have achieved that objectives and key results, and we have to check it out at the end of each quarters, and then also at the end of some annual. And we're just recommended to just qualify that objectives and the result we're just on a numerical basis. So for all these just objectives and the results are generated and by each individual, by each team, or the whole company, so that we can set up the direction we have to go. And when it comes to daily job appraisals, and we need the code reviewing process, because the code reviewer know that actually the results and the achievements of the engineers. And also we have the meaningless discussions, the video conference discussions. so that whether that we're going to have provides a kind of a technical lead in that occasions. And also snippets is supposed to be written on a weekly basis. And when I look at the snippets, then we can know that one specific engineers was doing what. And next one is the Google resume. And this resume is the sort of resume. We write the resume for one thing for that appraisals, but it's really flexible in working in Google, so that some engineers have to be shifted from one specific project to the other one. So we needed to appeal our own achievements in some specific projects to the other teams, so that we can just specify and appeal our specific achievements and contribution to the Google can be specified and written in the resume. And based on all these informations, we have a performance review meeting and just once a year. And basically, the colleagues evaluate its own colleague engineers. So that first we just appeal that this is our achievements, a result of this specific period of time. And also we just appoint some colleague who is going to review and evaluate my own achievements. For example, that the colleague engineers and they evaluates myself and some of the engineers that this is the part engineers who come up with the really great coding and they're very good working on the coding and debugging. This is the colleague engineers inter-evaluation, so that it's really precise and accurate. For example, if just a supervisor evaluates that engineers, and some of the engineers who is good at only for the presentation, I get good remarks, but it's not that in Google, because that's the colleague engineers evaluate with each other. And what we're required as engineers in Google is that first of all, we need to do that voluntarily, and also we need to enhance our expertise, knowledge, and the skills. And we don't wait for any instruction from on a top-down basis. We don't wait for that the instructions and the order from the supervisors, so that we're required to voluntarily find out the improvements and what we should do. And if we find out to discover something to be fixed, we need to fix ourselves. And also we always discover the bugs or some of the problems and the different projects. And first we focus on our own projects, and so that if you think that it's really easier for you to just fix the bugs by yourself, then you can do that. And basically we are supposed to work as a team. And also we need to review it by just the team members, so that our basic concept is working as a team, not individually. So it's impossible in Google to do something by himself or herself alone. We need to work as a team and also reviewed and evaluated by a team member and colleagues. So that's why we need to come up with a system, a project idea that's an idea our colleagues and engineers can catch up with. And also for the requirement is that we need to catch up with the changes within the Google. Since I just joined the Google in the past year, that I myself experienced a lot of changes. So we're just working on the rules and ideas when we just joined the Google, and we failed to catch up with that and all these changes. So we need to just focus on what's going on and what have changed internally. And this is just a day and a Google engineer, and this is the office and the room and the Google office in Tokyo, and engineers are working just like this, and they're working very hard and concentrated hard, and it works. And after the work, we play together just like this. We also play a lot. We're gaming here. And this is what we are working and spending a day. And also would like to live up to your expectations after this, or we'd like to achieve even more than you have expected to us. That's what we try to achieve. So that's about my presentation. So do you have any question? May I? You mentioned the 20% rule. They're going to spend the 20% of your working hours for what you like, anything you liked. But the rest of the 80% you have to work on, even what you would not like to do. Is that what you mean? And basically, we can appeal and what we would like to do, so that it's not that 80, not the old 80% is what we don't want to do. The rather we're going to say that the 20% is really brand new things we have never experienced before. That would be the correct way to say. So the 80% is that what we have been currently doing. So, and then this 20%, and we're trying to come up with that the brand new thing is, and also that the collaborates with the other engineers which is working for the different projects. So this means that if we just concentrate only one single thing is on 100%, so we're going to have some narrow-sighted views. So that's why we need to expand our views, or we're going to have the creative ideas. And this is the major objective for this 20% rule, I think.
Thank you. Thank you very much for your presentation. Thank you. So Google Labs is selected from that 20%? Right. Yes.
出てないプロジェクトの方がたくさんあるんで、はい、
There are many more projects that have not been selected. Thank you. I understand that information sharing is important. For bug database, what kind of tool do you use? I think it's made in-house. It's an in-house database. Is it an easy tool to use? One of the easiest that you have ever used? Well, I wouldn't say it's difficult to use. And you're using Perforce for source code. Everybody's using Perforce? Yes, because we share the same repository. But there are some discussions about changing from Perforce. For review, you are using some kind of special tool made by the author of Python. Is that going to be published somewhere? Google Video, if you go to Google Video, you can see the video where he did a tech talk, but the code is not published because in the back end, it's relying a lot on Google infrastructure, so I don't think it would be usable outside of Google. Okay? When you invent something great, when you make something great, how do you let everybody know? I mean, the employees of Google, how do you share that information? We have demo link site in our company portal, so we can use that, or we can send it via mailing list. We can also use Tech Talk. So how long do you spend on Tech Talk? You do that every day, you said. One talk is about 1 hour. And there's no need for everyone to participate. And at Mountain View, we do 1 hour times, maybe 3 or 4 times every day. And if you're interested in a particular topic, you go and listen. Okay, thank you. And sometimes we invite somebody from outside of the company to present. And if you go to Google Video, you can find what kind of tech talks have taken place, especially the ones where we invite somebody from outside.
Thank you very much for the interesting presentations. And I think that engineers and the other companies probably get involved in some discussion about marketing matters and the business, what is the business case, how much profitable is this technology, or that kind of things. So do you also get involved in that kind of marketing matters, discussions, and when it comes to projects? How do you relate to that, the marketing matter? And when it comes to profitability, it is not we prohibited to think about whether to be profitable or not. Rather, we are just told to think about that the usability, how convenient and useful for the users. This is the primary focus we should have. For example, we try to use some technology within in-house so that if it cannot be used in-house, even in-house, that cannot be that can be obsolete and it is not useful. So that, yeah, this is our primary focus of it. Thank you.
You said in the beginning that developers hate to write documents. When it comes to progress report, well, I think information sharing is important. So how do you motivate the developers to write these documents for progress reports? Or how is it done? How is it done? Well, when you use somebody else's design doc, well, design doc has to be there. If you just look at the code, you don't know what's going on or what it means. So you write the design doc to help yourself in 1 or 2 years' time. So it's for you too. With regard to snippets, when you try to assess yourself, and if you don't write snippets, you don't remember what you did 6 months ago. You might have done a great job, but you forget. So on a weekly basis, it's easier to write these reports because your memory is still fresh. So we write these small snippets, and then when you look back, you see how much work you have done. So basically, you do it for yourself, for your own benefit. And the company provides the necessary system too. Yes, that's right. Thank you.
And a lot of question about the documents. What would be the volume of the design deck? How much of that document do you generate with the design deck? For example, one specific project you have, and how many pages, and how long do you take? How long will it take for just how much of the time you spend on that writing the documents a day? Actually, and we don't have to just emphasize so much on the writing documents, so that we don't spend so much hours, so that they initially, and when we start up the projects, and just in the initial first to second week, we spend some time on the documenting, and also just we and updating while developing. And it's not that with that documentation, anything goes well, so that we just put down the backgrounds or points, or just the high-level designing concept, or the consideration and security, or the monitoring plan, and that. We don't have to put down so much in details, and just if we can have some high-level and outline, and for example, positions where that the sourcing code is in the repository, or the monitoring server address, so that kind of key information should be there. But that's the minimum requirement, so it's not that voluminous documents. It should be, and that depends on the project. So if it's some sophisticated system, we need to just put down a lot, but that depends on the projects. And also, we make we try to make it that we try to have some and clarify the focal points. So first, we just starting from the leftly, from her designing, and just when the project goes, that we're just gradually just make it more details and for making improvements. That's the stage the process. That's about it. Thank you.
プロジェクトがいろいろと
I understand that there are different types of projects, different sizes and periods. When you participate in a project, when you write the design doc, how do you decide on the members that would participate, or how is the project managed? Is it done by the person who's responsible for that project? Yes, basically the developer finds the project that they want to join, and they join or they make their own new project. If you have a lot of time on your hand and you're asked to join a particular project, you join. So basically the decision is made by the developer where and how to commit to a project.
なんかいっぱいある。
どちらか指していいです
あ、
か？
はい。じゃあどうしようかな。じゃあ前の人かな。
Yeah, thank you very much for the presentation today. For developer, I think that's your development environment is the closer to the ideal environment. But it's just similar to the former question, but actually there are a lot of people also working together with you who are not actually the developers. But how then all of the people are working? Are the people other than the engineers, the developers? Yes. Yes, there are a lot of people who are not the developer engineers working together with us, but and the product managers are the persons that we get so often work together with us. They are the coordinator. The developers just can have the free hand to develop anything, but the product manager and try to coordinate with that. For example, the legal matters or marketing matters, sales matters, and all this coordination that are done by the coordinators for just organize the project as a product. So you don't have any direct communications or involvement with some people. Yeah, that depends on the project. So I don't get so much involved in the front end part of the project, so that I don't know exactly about it because I'm working on a in-house infrastructure, so that I don't have so much opportunities to work together with them. Thank you very much. At the next, I have another question, and when it comes to developments in overseas environment, you have just to work it there in the U.S. and learned how to develop it, but how do you evaluate the Japanese developer? Evaluation on the Japanese developers, and it's a rather difficult question for me. But how I evaluate, is that a question? For example, that their working style is just wasteful in times, or and this is what I'm just feel myself. So that how do you think about it? This is the Japanese engineers, including myself, but they don't appeal so much. And there are a lot of able engineers, but it's not that also the engineers come up with that every time they come up with a great idea, but they come up with a lot of ideas, and including some minor ideas. But I think that the Japanese engineers tends to be just modest, and so that the Japanese engineers are not so much capable and appealing. All right. Yes. Thank you.
So when you write codes in Google, you have certain coding rules. Is the coding rule confidential, or is the rule going to be published in the future? I remember reading a discussion about that, but I don't know the current status of that. There is an opinion that we should open it, but some pieces are too specific to Google, so other people question whether we should do that. I think many people here today would be interested, so please think about this. Well, we have some open source library, so I think that's pretty close to what we're doing. Okay, thank you.
Now, performance appraisal, you mentioned that basically your colleague evaluate you, not the supervisors, right? And also you said you find out that the job is and project voluntarily by yourself. So what is the responsibility of supervisors? And is there any supervisor in Google to start with? Yeah, when I say the supervisor, yeah, there's a person is supervising. Yes, there's a person. So from the perspective of the engineers, and there's some difficulty. There are a lot of supervisors, so that sometimes we have some person to which we can ask some questions or consultations. So there's an overviewing, and there's the internet connections. So for example, sometimes my supervisor and some supervisors that recommended and they tell me that there are some of the interesting projects. Or so from the point of view of the engineers, we have some difficulties that the supervisors can follow up on without a little problem. That's all. Thank you.
Okay, the time's up. This is the end of the presentation. Thank you very much for your attention.